All right, kids. Good morning. Happy Friday. There's no note card today, but I am going to have you do a few things with Pascal's triangle with what we did yesterday. And as you can see, today I have a colored Pascal's triangle. If I go over here, you see a completed one similar to what we did yesterday. So if you were wondering which this number, I put a question mark on this yesterday, and I said, oh, I got to get right to the spot. Hold on. Why am I not getting there? Right here, I said, which would be this one, right? And I said, what do you think it would be? What's your guess? And I put a question mark there. So what's that number say? I don't know if you can see it, but that number says 252. So that was that last number that we had on yesterday's chart. So today, what I want to talk, and you fill it out. So yesterday, hopefully you filled this out. You figured out that you're adding up. Do you remember how this works? You're adding up the two numbers, like the 4 plus the 6 right here would give me the 10, right? The 35 plus 35 would lead to the 70 below. The 5 and the 1 would lead to the 6. So this idea that in any case, in any moment on here, if I add two of them above, it leads to the one directly below, right? So they kind of work in this notion of triples, like this is all one set right here, you know, and they can work everywhere on the whole board. If we circle like that pattern, we could say the two top numbers add up to the one directly below it, right? And that's how this pattern works. Now I want to talk about the actual number patterns within it. So we're going to back up a little bit, or not back up. I'm going to go to this sheet right here, and I want to show you some of the patterns. And the one we're going to talk about today is going to be the third. We know the first rows are always ones, so ones down the edges. We know these are the counting numbers, or the natural numbers: 1, 2, 3, 4, 5, 6, 7, 8, and so on and so forth. What I want to focus on is this row of numbers right here, which also keeps going, but we're just going to focus on this set of them for now. And I want to talk about what those numbers are. So I'm going to write these pattern numbers down in a pattern, and I want you to tell me if you can see what's happening from one to the next. So if I say we have, excuse me, 1, and then the next number, we're going to put a comma. 1, 3, 6, 10, 15, 21, and 28. So in my class yesterday, a couple of my students picked out this pattern and talked about it. They knew how it happened. And I want to know if you guys can figure out what's going on from 1 to 3, 3 to 6, 6 to 10, 10 to 15. What's the pattern? So I'd like you guys to pause. If all my teachers could pause and see if anybody understands or can figure out what that is. So pause now and see if students can figure this out. Okay. I hope you're back. I hope you figured it out. One of the interesting things about that pattern is that it's not linear. It's not moving at the same rate every time, but it is predictable. And that's interesting. This idea of something being predictable is really important. So when I say predictable, what I mean is that I can predict what's going to happen next based on what I've seen. So if I know right here that these two numbers from 1 to 3, 3 to 6, 6 to 10, 10 to 15, 15 to 21, 21 to 28, I think the next number has to be, let me make sure I'm going to say it right, because that's plus 7. It must be 36 is, I think, the next number on the chart in this line. So if I was going to extend this pattern, I'm pretty sure the next one is 36. And you might say, well, maybe we figured that out, but what's happening? How did we get there? So what I want to look at, or I want you guys to notice, is that if I say, how did I get from 1 to 3? We went plus 2. Okay, so let's do the next one. How did I get from 3 to 6? We went plus 3. How did I get from 6 to 10? Notice what's happening. Plus 4. How do I get from 10 to 15 plus 5? Do you see the pattern? Plus 6, plus 7, and the one I figured out just now, plus 8, right? So it's this idea that the numbers are growing by a predictable amount, which is really fascinating. Now, there's a name for this pink set of numbers right here, or the numbers I wrote up there. And the name for these numbers, they are called in pink, not the blue ones below, but the pink numbers are called the triangular numbers. And I want you to do something for me. So I want you to, in your assignment, to do this for me. I want you to show how a triangular number works. Triangular numbers. So 10 is a triangular number. I'm going to show you how. So 10 is triangular. It's called a triangular number because watch what I'm going to do. I'm going to draw this number. I'm going to put a dot here. I'm going to draw it with dots. And then I'm going to put 2 dots below it. And then I'm going to put 3 dots below that. And then I'm going to put 4 dots below that. Notice that my triangle is growing every time, made of dots, every layer getting one more. How many dots did I just draw? 10. Look at that. 10 dots, right? That's a triangular number. 10 is a number that can be arranged into a triangle. Let's try it with 6. So we're going to try it with 6, even though it's we're going to go down here and we're going to say 6. So 1, and then 2 dots in the second row, 3 dots in the third row. Oh my gosh, another triangular number. 6 can be drawn as a triangle. Let's try 3. 3, this is a very simple triangular number. Look at this. Another triangular number. Aren't these great? So these are triangular numbers. I want you to draw 15, 21, and 28. I want you to draw them in your notebook and write triangular numbers and write these down. So that's one amazing pattern from Pascal's triangle. And it's in this third diagonal. We can also see it if you look. Obviously, everything is symmetrical here. You can also see it right here. Right? Same numbers. So those also happen because the same numbers are symmetrical throughout this entire chart. Like if you pick the same diagonal going in each direction, it will be symmetrical. That's fascinating. So triangular numbers, that's one thing. Why are they triangular numbers? How do we predict them? What's coming next? Totally great. I want to show you another cool detail about this. Let's go to this one and let's take a look. I'm going to move this over just a touch. Let's take a look at this. I'm going to start adding up all the numbers in each row, right? And when I say row, I'm talking like this way. So this would be row 1. So I'm going to write right here. Oh, I'm sorry. I got to go back to here. This is going to be row 1. That's our top row. This is going to be row 2. This is going to be row 3. And what I'm doing is I'm just going to point to it. Like these are our rows, right? So we are now going to add up the rows, right? So row 1, row 2, row 3. So row 1, the answer, I'm just going to put equals 1, okay? Row 2, maybe I should change color. I think I am going to change color. Row 2, I'm going to add up 1 plus 1, and it's going to equal 2. Row 3, I wish I had like Khan Academy thing where I could just like very quickly. Row 3, we're going to add up these 3. 1 plus 2 plus 1 equals 4. I'm going to add up these. Let's change the color again. Let's go with green. 1 plus 3 plus 3 plus 1. That would give me 4 plus 4, which would give me 8. Oh my gosh, look what's happening. Row 5, let's do red. 1 plus 4 plus 6 plus 4 plus 1. And we're going to say that would be 5 plus 6 is 11 plus 5 is 16. Now, what do you think is coming next for this row and this row and this row and this row? So I want you to figure those out. Now, you might be able to like add them all up, or maybe you see a pattern. Like maybe you look at this and say 1, 2, 4, 8, 16. What's going to happen next? So as we go down the rows, so we had row 1, row 2, row 3. Now this is row 4, row 5, row 6, row 7, row 8, row 9. What's going on? And I'm going to give you one more thing that's actually quite interesting. Oh, no, I didn't want to do that. Before we go, I want to give you one more thing to think about. Okay, the last thing I want you to think about. If I take the numbers and just turn them into numbers, if I go in the rows again and I just say, all right, let's say up here, I got 1. My first number is 1. My second number is 11. If I don't add them, if I just put them together, my third number is 121. My fourth number is 1,331. This is a totally different pattern. Can any of you, and my fourth number, 1,000 or 14,641. Now I'm not adding, I'm just putting the numbers together. There's a pattern happening here too. This is kind of like bonus. Can you figure out the pattern? What is the pattern for this one? There is a pattern here. So once again, all these crazy patterns in Pascal's triangle. Okay, so some things to think about. All right, pretty great. Pascal's triangle leads to a whole bunch of other cool things. So we're going to talk about this right here. I want you to see if you can figure out the remaining rows. I want you to see if you can figure out on this one, if you can draw the triangular numbers and maybe predict the next three after 36. What's going to be the next three numbers? I'd like you to try that and see if you can find any other cool patterns in Pascal's triangle today. Okay, I'll have an assignment up, pretty basic, just asking you to kind of write, sketch some of this in your notebook. And that'll be it for today. Make sure you're catching up on your con. Make sure you are completed with yesterday's Pascal's triangle and that you've done your surface area project from Tuesday and Wednesday. All right, kids, have a great weekend. You know, we're down to, I think, like 3.5 weeks left. I think that's right. I think it's 3.5 weeks. So have a fantastic Friday. Yay, Fridays are awesome. By the way, last CNN 10 of the year is today. So if you aren't in my class, but you're at home and you want to watch it, you should, because they start up again next fall when school starts. All right, kiddos. Have a good day. Bye, everybody.